Hi guys, welcome to this page of the notes, and again, here's what we're doing. We're looking at partitioning a directed line segment. So, let's find the line segment. Give me a second here while I graph it. -4, +4. Right there, there's A. That's going to be the point -4, 4. Then I need point B, 2, 1. 1, 2, 1, right there. B is at 2, 1. Let me draw this guy. Yeah, okay, that's pretty good. Now remember what we said we were going to do. Instead of trying to do distance formula, partitioning the distance formula, the length of the line, and then trying to go back and figure out what... No. Break it into its components. Rise over run. Rise, run, and go ahead and figure out what those are. First, I need my ratio though. Alright, so here we go. The ratio, I want one part, that's the part I want, over the whole. Well, the whole will be 1 plus 2, which is going to be 1/3. Alright, so what is it? Well, my rise is simply count down 1, 2, 3. Since it's down 3, that's going to be a -3. My run is going to be 1, 2, 3, 4... Sorry. 1, 2, 3, 4, 5, 6. 6. Alright, so now to find my partition, I multiply the rise, which is a -3 times 1/3. Well, that's easy. The 3's cancel each other out. You're left with a negative times 1, which is just going to be a -1. The run, which is going to be 6 times 1/3. 6 divided by 3 is 2. All right, so here we go. I need to go on to find my partition, I have to go down 1 over 2 right there. That point right there is the point -2, 3. So my partition point is at -2, 3. Head on over to the next page of the notes. I got a couple more of these for you. Now that we're getting the hang of it, these are going to go really pretty quick. They're not that terribly challenging once you know how to do them. Let's plot A and B. Alright, so right there should be A, which is at -6, 5. B, right there. B is going to be at 2, -3. Let's see how well here. Let's try and draw a line there between those guys. Not the best line I've ever drawn. Actually, here, let me fix it because I think I can do better. Yeah, I'll take that. That's a little bit better. All right, anyway, remember, no distance formula, none of that stuff. Split it up into its components, rise over run. There's my rise. There's my run. Here we go. The ratio. The ratio is going to be 5 over 5 plus 3, which is going to be 5/8. All right. Oh, sorry. I want rise first. Let's do rise. All right, my rise is 1, 2, 3, 4, 5, 6, 7, 8, but it's down, so that's going to be a -8. The run, let's see, 1, 2, 3, 4, 5, 6, 7, also 8. Okay, so then my partition, let's see here. We're going to take the rise and we're going to do a -8 times 5/8. Oh, look at that. The 8's cancel, you're left with a -5. The run, 8 times 5/8. 8's cancel, you're left with a +5. Let's find that partition point. So it's going to be down 5 over 5. Right there. So P is at the point -1, 0. It's right there on the x-axis. P is -1, 0. And guys, just like that, right, we're starting to get really fast at these. They're not too terribly tricky. Whether I give you a straight number line or I give you a directed line segment, right? We're doing the exact same thing, writing the ratio, multiplying the ratio by the absolute value of whatever whether it's the line segment or our components, the rise and the run, to find that partition point P. Again, what this means, right, is from A to P, that is 5 parts, and then from P to B is 3 parts. So the whole is 8 parts, right, where this represents 5 of the 8 parts, or a ratio of 5 to 3. So 5 to 3. Anyway, here we go, one more. Once again, we're going to plot these points here. Let's see. 7, 2, right there. So that's going to be A. 8, negative 3. 8, negative 3. That's all the way over there. Here is A at minus 7, 2. Here's B at 8, minus 3. Oh, yikes, I can tell already. That's not going to work out. Try one more time here. Yeah, that's better. I'll take it. It's not perfect, but I'll take it. Remember, we need rise over run. Perfect. There's my rise, there's my run. All right, let's do it. Let's find the ratio. It's going to be 2 over 2 plus 3. So how about 2/5? So I want to find a point P that is 2/5 of the way across the line. Or we divide this line segment into a ratio of 2 to 3, or 2/5. Point P will be 2/5 of the way. So here we go. My rise. The rise is... it's a minus 5 because I went down. The run, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 is 15. My partition. Well, let's see here. We're going to multiply the rise, which is a minus 5 times 2/5. The 5s will cancel, negative, minus 2. What about the run? 15 times 2/5. All right, slightly trickier here, but still not terrible. You'll simply take 15 times 2, which is 30. 30 divided by 5. Or you could do 15 divided by 5, which is 3, and 3 times 2. Either way, you get 6. Down to 1, 2 over 6. Oh, look at that. Point P, once again, negative 1, 0. I love it when that happens. Exact P is in the exact same position as it was the one above. The ratio is different. The points are different. It just so happened point P comes out to be negative 1, 0. All right, one final question here just to sort of see if you really kind of get what it is that we're doing here. And it's this question. What can you conclude about the point P, so our partition point P, that partitions a segment into a ratio of 1 to 1? How could you find the coordinates of such a point? So if my ratio was 1 to 1, or, remember we can write that as a fraction. The part I want, 1, over, add the parts together, 1 plus... Wait a second. So all they want me to do in a ratio of 1 to 1 is divide the line segment in half. Find the halfway point. Well, so the partition The partition will be the halfway point. How do we find the halfway point? Midpoint formula. So the midpoint is x1 plus x2 over 2. y1 plus y2 over 2. So if ever, in the event, I ask you to divide a line segment into a ratio of 1 to 1, you know the partition will be the halfway point, right? Because the ratio comes out to be 1/2. That's the halfway point. How do we find the halfway point? Midpoint formula. All right, guys, that takes care of this sort of idea of partitioning a line segment. Thanks so much for joining me. I had a great time taking a look at it with you, and I'll see you next time.